Okay, here we go. Uh, I know that on the right here it shows multiple chapters in each lesson, but each of these videos will only contain one lesson. And I know that this says 1.1 real numbers is part of chapter 1.1. But I like this chart, and you'll see why in just a little bit. Now, real numbers is split into rational numbers and irrational numbers. And irrational numbers is a category all its own, and it's numbers that can never be written as fractions. These include the number pi, e, square root of 2, cube root of 7, etc., etc. This is an infinite set, and believe it or not, it's bigger than the rational numbers. Uh, Rational numbers are numbers that can be written as fractions. These include all decimals. Eh. They include fractions. They include integers. Okay? And when I say decimals, I mean uh, terminating decimals like 2.5. And I mean repeating decimals like 1/3, which is 0.3333333333333, etc., etc., etc. Okay? Uh, so rational numbers split off into integers, which also split off into uh, decimals and other fractions. Okay, so integers and then fractions and decimals. But we're not going that extreme with this. And notice with integers, it's got what I call positive and negative whole numbers. And then whole numbers are these with the number 0. So integers would be whole numbers and negative integers. And then natural numbers also are called counting numbers. By the way, that's not a hashtag. It's called numbers. And why is it called counting? Because if I tell you to count off, you start at the number 1. Now, why is it that I really, really like this chart? Because irrational numbers are irrational and real. This chart never jumps from one side to the other. It stays on its side and only goes up. So if it's an integer, it's also a rational number and a real number. If it's a natural number, then it's a whole number, integer, rational number, and a real number. So I really, really like this chart. And I think it's the first 5 problems on chapter 1.1 that include labeling your numbers that you're given on what type of number it is. So I really like it. What I don't like is changing documents because I have to reset everything whenever I do that. Now, order of operations is always done from left to right. And I really don't like PEMDAS unless they organize it this way in groups of 2. But my favorite way of organizing the order of operations is this way. Parentheses, and notice the word or exponents. Multiply or divide, add or subtract. So if you come to multiply before divide, then you do the multiply. But if you come to the divide first, you do it before you do multiply. So I really like this setup, and I like it for another reason. Because if you are simplifying, and I'm going to shortcut, if you're simplifying, you go down this order. So you do parentheses or exponents first, then multiply or divide, then last is add or subtract. But if you are solving, you go up the order. So the first thing you get rid of is add or subtract, then multiply or divide, and last, parentheses or exponents. And since you're doing the opposite order, you do the opposite of what you're trying to get rid of. So I really like this setup for the order of operations. Now, I like stories. I really like stories. But before I get into the stories, uh, commutative works and commutative and associative work for both add and multiply. When you've got something hugged up to itself, to like 2 variables hugged up, or a number hugged up to a variable, or a letter or a number hugged up to a parenthesis, all of those imply multiply. Now, commutative and associative apply to both addition and multiplication. Distributive is the oddball out. So now, commutative. At the beginning of the day, I commute from home to school, and at the end of the day, I commute from school back to home. Notice my order changed. Okay? And I need to change my font. There we go. Order changed. Now, the next thing. And also, notice I keep changing color. Color increases memory. Now, the next story. A came to a party by herself, and she met this couple, B and C. Well, B was a bit of a jerk. He decided to go home with A, and left poor O.C. out in the cold. Notice ABC, ABC. So the order stayed the same this time. What changed was the grouping. Okay? Now, like I said, distributive is the oddball. Notice A shows up once on the left, but twice on the right. So A came to a party by herself and met these two gorgeous hunks, B and C. And she decided to distribute her time evenly between the both of them. And if she was anything like my dad, she got caught. Because, yep, my dad got caught. There were these three girls, and he decided to set dates with all three of them on the same night, like a dummy. So he got caught. So A shows up once on one side and multiple times on the other. Now, combining like terms. Add or subtract x's to x's, y's to y's, x squareds to x squareds. Notice x's and x squareds are not the same. So it would be kind of like this. Sweater jacket, leather coat. If you did inventory and put a sweater jacket in the same column as a leather jacket, you would get your butt in trouble. Because a leather coat ain't the same thing. Now, an example of equations and putting things together and combining like terms would be like this. Okay? Let x's be apples, y's be oranges. I've already got 7 oranges and 1 apple. And I buy 5 more of each. Okay? Using x's and y's, I've got 7 y's and 1 x. I buy 5 more of each, so 5 x's and 5 y's. Well, let me go ahead and write it, because this is how I like to do it. I like to combine my like terms this way. Typing it out, yuck. I don't like going across. I really like doing this. So, 7 oranges plus 5 more oranges. 7 plus 5 is 12. 1 apple, 5 more apples makes 6 apples. If you look at it like that, is it really that big a deal? I don't think so. Now, in Blackboard Shell, Chapter 1 folder, there's a translation page. Look that up and print it off. and use it. Sum means add. Sum goes where and is. So you bring your x down. You bring your 4 down. You put your plus where the and was. Are or the word is, both of them mean equals. And then you just bring your 7. That is done. Is it that easy? Yes, it is. Because it says translate to symbols. It does not say solve. It says translate to symbols. That's all you got to do. Okay? I promise it really is that easy. Now, your order of operations. You came to this parenthesis before you came to the exponent. How do I know? Because 3 plus 4 I can do. That is 7. 7 squared is 7 times 7. That tells me 49. Could I put this in the Goodbuddy calculator, Mr. Goodbuddy? Yes, I can. Calculators are there for a reason. So do the same thing here. And then it says to add those two things. And when I do, and I can use Mr. Goodbuddy, I could have put the whole thing into the calculator. Now I already know that this part of it is 25. So I really don't need to do that part of it again. But I do need to do this. 2 times 3 is 6. 6 times 4 is 24. So when I add that, I get 49. Shortcut as much of your work as you can. Okay? Because why do more work than you gotta? Now, on your calculator, you've got divide, times, minus, plus, enter. All of that's on the far right. And then you've got, right in front of enter, you've got 3. And then you've got this little key right here, which is your minus key. Why am I telling you that? Well, I am so glad you asked that. Because sometimes when you're doing this problem and this problem right here, sometimes you got to use this minus key, and sometimes you got to use this minus key. Okay? And that's what I need to show you. So this minus key can be used here and here. Of course, plus and plus. This one needs to be used here and here and here and here and here.